Welcome, everyone, to the Mega Alumni Podcast. My name is Nehal, and I'm a graduate student at The Ohio State University in the Department of Mechanical, Aerospace, and Nuclear Engineering. Mega is our graduate student organization, and as a part of this alumni podcast, we are hoping to connect our current students with the alumni from our department. Uh, we also have a lot of different social media websites and our own website that are in the YouTube description. Please feel free to check out what other events we do if you are a student from our department. And we will also be posting short form clips of this podcast on our LinkedIn page as well as our Instagram page. So if you prefer watching short form clips of the podcast, you can go ahead and follow those pages. And we'll have the full video with topics clipped in our YouTube description as usual. So without further ado, let's welcome our guest for today. That's Mohamad Al Nashar. He has done his bachelor's and master's degree from the Ohio State University, and now he's working in the Honda R&D department. Uh, so yeah, I'll hand it over to you, Mohammed. What would you like to discuss, and just introduce yourself about your role and work.
Yeah, I graduated from Ohio State with a bachelor's in mechanical engineering, um, and I continued with BSM with the BSMS program. Like in my junior year, I was doing some undergrad research, and I decided that I want to continue to grad school. So I combined both. I did the combined program and continued with the master's, and then went straight to the industry.
Got it. And so currently you're working at Honda. Is Could you give us some description or a little more, give the viewers some more idea about what you're doing at Honda right now?
Yes. So during my grad studies, I was mostly focused in simulation and optimization methods. Uh, so at Honda right now, my job is doing simulation for future products and in the noise and vibration department. So it's mostly like modal analysis, frequency response for the structures, those sort of things. Yeah.
Got it. Got it. So as a part of your job, do you actually get to work on, when you said you work on the future products, are you actually working on like the next Honda Civic itself, or are these more kind of vehicle prototypes, and then those internally get converted into what the consumers buy off of the showrooms?
Yes. So uh, we basically work because it's simulation. So the idea of using simulation is to predict the performance of something that does not exist. So we
Mhm.
work on prototypes first. We ensure that everything in CAE and CAD is okay, and then they build a physical prototype car, and
Gotcha.
then physical testing occur after that. But everything else early on is everything is simulation. So that's where we come in basically.
Got it. Got it. So I'm also doing a lot of simulation work. So I'm quite interested in how everything works in the industry environment because I've never worked at a company before. So as you were saying that you kind of work with these prototypes, and I'm assuming here that there will be a lot of different kind of simulations going on for the different components and different aspects of the car as it is being designed, right?
Mm.
So as a grad student, like we are kind of very we have a niche thing, and when we are doing a simulation also we are kind of pigeonholed and focusing on this one aspect of what this one problem. But in an industry, and let's say when you're designing a car, there's so many things going in there, and you
Mm.
say that you're working, let's say in the noise, vibration, and harshness department. How exactly do you coordinate with the other R&D sections, and I'm guessing especially the people who are doing simulations but of other things?
Mm.
And how does that alter your workflow, essentially?
Yeah, yeah. Um, Actually thinking about going back, like comparing to grad school. I know in grad school we usually focus on like a microscopic problem. We just laser focus on a specific thing. But I feel like that in grad school, not just like solving a problem, but it teaches you how to think, how to look up solutions, research stuff. It's just like training your mind to think in different ways. Uh, so in the industry, it's kind of a similar thing. You're assigned maybe, let's say that for the sake of example, just maybe like a part a part of the car chassis that you're responsible of ensuring that okay, it meets the performance, meets target, etc. Uh, and you have some room to think outside the box to propose new design modifications and stuff. But going back to your question, like how does like other departments in R&D work together? We basically have a one huge meeting that, like, say the crash group and noise and vibration group, the handling group, the steering group, they all come together and they say, okay, this part is okay for us. Maybe crash says, no, this part is not okay for us. Then we all go back to the drawing board and try to find a common solution. And everyone is checking their targets, like in a circle, everyone checking. And at the end, we converge into a solution where all groups are happy, basically, and we proceed with that. That's how it works.
Got it. Got it. Uh, Interesting. And so I'm also curious. So when you say all the other departments talk and you come to some sort of a compromise, is there any simulation that you end up doing, and do you have the compute resources to do a simulation where maybe everything is being considered together, or at the end, like the simulations are still kind of quite modularized for each aspect, and then you kind of put
Right,
pieces together for a puzzle, or is there like a granddaddy simulation that kind of and
right,
counts
right.
for everything? Yeah.
That's the dream, right? Like when you're in grad school, you're looking into these multi-objective
Right.
optimizations. Like, okay, can I include all these variables into one
Exactly.
problem? But in reality, as I realized, it's much difficult because first you don't have like 5, 10 targets. You have maybe like
Mhm.
50 or 100 targets. And second thing is maybe like our simulation model is is not necessarily the same as the crash group simulation model or the
Mhm.
handling group simulation. The content of the model is different, uh,
Right.
and the mesh size is different, and all these intricacies is different. Like there's a lot of differences. It's very hard to kind of combine different domains into one just problem. So
Right.
we end up evaluating somewhat separately. We try to combine metrics as much as possible, but it's not all in one, basically.
Right. Right. Yeah, that makes a lot of sense. Uh, and I was looking at your profile and I was seeing that while you were here at OSU, a part of your research here involved, writing some of your own code, like Python scripts, for doing some of these simulations and doing a lot of this work. I'm curious now that you're working in a company, does that still involve a lot of in the R&D team itself?
Mm,
Because maybe you're developing a lot of new things,
mm,
things that are state of the art. Do you still do code development and model development a little bit over there as well? Or is it more, since it's a company that's focused on a product, the
right.
car,
Mm,
are you just more working with whatever simulation or modeling tools, let's say other companies like Ansys or MATLAB might license out, and
mm,
then use those to design
mm.
essentially?
Yeah, that's a very good question. So coding in general is not very taught in undergrad. It's like very basic stuff in undergrad, and a lot of undergrads, including me, ends up hating it, coding in undergrad. But in grad school, I realized like if you wanted to create something new, especially nowadays, it's it's highly likely it's in digital form. So
Right.
you need to be involved somewhat in coding. Uh, Now, at work, as you mentioned, as you expect, the majority of the tools we use are commercial tools like Nashar, Abacus, etc.
Okay.
Uh, we use scripts to submit the simulation. Like we rarely use the user interface, but they're very basic scripts. Like there are templates, and you just like modify some parameters, and you submit the script, submit the simulation. But
Right.
I found that knowing some coding, having a background in coding, kind of gives you an edge in the
Mhm.
industry. Because, like I said, a lot of people were not very exposed to, like, for example, Python, maybe a little bit of MATLAB here and there, but not Python and other languages. And I think you can have an edge in the industry. You can create some automation tools.
Right.
You can, yeah, it gives you an edge basically.
Right. That makes a lot of sense. And I think, yeah, whenever folks reach out to me as well, like, hey, what as an undergrad, what should you be doing? Or as a high school student, it's usually like, yeah, get your hands wet with, coding, be comfortable with doing some of
Mhm.
that because you'll quickly realize you can build a lot of things. And it's quite accessible today with, so many online resources to just get started. So it's a
Mhm.
great thing to learn, and clearly it can help you in a future job role as well, as Mohammed said. Uh, right. That's good to know. So the maybe now we can talk a little bit more about your grad school research and how that kind of maybe paved the way to your current job, or if that affected your uh, job at all. So I believe when you were here in grad school, you were working with a lot of structures, topology optimization. You're working with, I think one of your projects, which I found quite interesting, was trying to reduce the mass of the problem by efficiently guiding electromagnetic waves in the structure itself. So can you talk a little bit more about what your research was at OSU?
Yeah, so I started first my grad research in optimization. So I was just exploring basic structural problems at first, understanding the code, how the code works for simple problems. And then there was some proposals that uh, caught my advisor's attention, multiphysics optimization, combining electromagnetic performance and mechanical performance, trying to design for that. It kind of fit, fits the domain that I was trying to explore. Yeah, so that kind of led to the Airforce Research Lab fellowship. We applied
Okay.
for it, and then uh, unfortunately, it was during COVID, so I didn't have a lot of face-to-face or inside visits and such. It was
Hmm.
mostly online. But like towards the end, I was able to kind of go there for a visit for like a month in Dayton, Ohio,
Okay.
right Patterson Air Force Research Base there. It was fun, yeah. It was kind of interesting collaborating with other people and working on new stuff, basically. Yeah,
Right. Yeah, that's pretty interesting. And you brought up the fellowship that you had won as well. So and this was during the COVID period, and I believe when you were transitioning from your bachelor's to the master's part, when you were probably
pretty much.
planning out a lot of these things, right?
Yeah.
So what was the like when you were discussing this with your advisor, what was the procedure for even thinking about applying for this fellowship? And kind of what once you did get the fellowship, what kind of expectations were from their side in terms of what research you need to finish as a
Mhm.
part of the grant of the fellowship.
Yeah. The process, I think it was a little bit different than other fellowships because this is like from a government side. They wanted someone with citizenship first.
Right.
Uh, they had to go through some clearance approvals and such. But then afterwards, it was pretty normal. We just had a weekly meeting with
Okay.
them. It was all via Zoom, and we were just sh- uh, sharing progress from our side in terms of coding and what results are we getting. Um, yeah, I think it was the expectation was to kind of make enough progress to write a paper
Hmm.
uh, and develop and keep developing this. I don't think we got to the point to write a paper, but we had a good draft. We kind of laid down main uh, the main ideas.
Right. Right. Got it.
Yeah,
And so, as a part of the end, like you were saying, unfortunately, since it was during the COVID times, it was mostly remote. But that last fraction where you did get to go to Dayton, like what was that experience? Like, was there any more hands-on experience you got at that for that small period, or was it still kind of modeling and not actually seeing any hands-on or any actual physical prototype or product?
yeah. It was mostly just on the computational side. It was
Okay,
just like coding. The project was very early in its stage, so everything was just like coding and trying to lay down the method,
got it.
computational method. Uh, Towards the end, we got to have some 3D printed parts,
Okay,
but no testing. It was kind of limited by the time, and during COVID, there was not a lot of staff, and
right,
as you know, everything was slow. And
right, got it. So from this from the grad research experience that you had and the experience that you had especially on the simulation and computational modeling side of things, uh, while looking for jobs and currently and landing your current job at Honda, were you specifically also looking for modeling related roles, and how did you skim out the right kind of job profile that
mm,
really fit or matched your research expertise.
mhm.
I'm kind of curious about that because I'm guessing the simulation modeling thing is I guess common across different domains.
Right.
So when you picked the automotive sector or like Honda, was that something you were very sure about, or did you apply for these kind of computational simulation roles across different
Mm.
places? Any if you got any other callbacks, and if you had to make a choice at any point, what went through your head as you were making that decision?
Yeah. Uh, Good question. So, as I progressed through grad school, I realized like simulation is like what I want. Computational tools, computational mechanics, simulation. This is what I want to do
Hmm.
in the industry. So, and I'm a car enthusiast, so I was like targeting car companies. I was applying for
Okay,
car companies mostly.
gotcha.
Uh, NVH was not something that I thought I would like,
Okay,
especially in undergrad. Like I wasn't very it wasn't very a fun subject for me. Vibration and systems,
right,
that was not the super fun class for me. But
right,
I realized like in the industry right now, it's actually pretty intriguing. It's really I glad like I chose this.
right.
So I was just applying for simulation positions basically.
Got it.
Something has to do with structures in general. I mean, vibration is structures, uh,
Hmm.
and I landed on this. Yeah.
Got it. Got it. And since you kind of raised that point about, the noise, vibration kind of area in general, maybe people who are doing research in that area are well aware of what goes on in there, but people not working in that area, and you kind of, finding out as you're doing your current job at Honda. Uh, what is the interesting things that you have found out about this area in particular, that maybe if some current grad student is also thinking about these roles, they should think about, and not not look over those roles because it still might have something interesting going on there. And with
Right.
for passenger vehicles, I'm assuming that it is quite an important thing because a lot of the customer experience is based off of what kind of noise and vibration they get inside the cabin. So it's from a selling or advertisement, a ride quality perspective, it is an area where each company, I'm guessing or assuming, is probably putting in a lot of R&D money to get that right.
Mm. Yeah, yeah. Um, Yeah. So the thing is with the noise and vibration, it's like I know in grad school we laser focus on specific topic, and I think my advice is when you look for a job in the industry, don't limit your search focus into that same topic that you did in grad school.
Hmm.
Because at the end in grad school, you're not just learning that very, I mean, you're learning that very specific topic, but you're also learning how to think in grad school, like
Right.
the thought process. So I think everyone can like try to make the search circle a little bit bigger in terms of searching. Like for example, I was not specializing in NVH when I was in grad school. I was doing structural simulation. It was it was not too far off, but not that the same exact thing.
Right.
So
Right. Got it.
yeah,
And kind of so kind of curious about you mentioned that by the point you were in grad school you realized that this simulation area or domain is kind of what you're interested in.
mm,
But I was also looking at since I believe working at Honda is your first like full-time job, I believe, right? So right after grad school, and you didn't have, right? So I was looking at your other experiences, and I believe you had some other campus jobs, and you had a co-op experience at GE in between. I
mm,
believe during your bachelor's itself.
yeah,
And I was curious what your experience was like on maybe those campus jobs on this co-op, and if it was different than simulation or if it was still in that computer aided engineering space, which
mm,
led you to actually, because I remember you even quickly kind of mentioned that towards the end of your bachelor's you realized that you wanted to do a master's and pursue research a little bit. So was a lot of the some of the maybe on campus jobs, some coursework, or this co-op that led you to make that decision that you want to do this BSMS
mm,
combined kind of degree, and get that grad degree right at the get-go.
yeah. So that was some time ago at the co-op. It was during I think a fall semester, so I had to take a semester off for it. But that's the
Okay.
only thing I was able to get at that time. Summer co-op internships are very competitive, as you know.
Right.
Uh, it was pretty good. So the co-op was I think the job description was manufacturing engineering. It was mostly CAD, so I learned a lot of SolidWorks, tolerancing and such on that
Mm-hmm.
job. Um, that was before my experience with simulations.
I see.
It was it was pretty good. I learned a lot, but I learned what is it like to be a design engineer, I guess.
Hmm.
But then in grad school, I was exposed to simulations and stuff, and I kind of drawn more to the simulation side more.
Got it. Hmm.
Yeah.
And so at least the first experience of your simulation related work probably still came from the graduate coursework or just research directly, or did you have any opportunity during the bachelor's coursework or something where you found an interest in simulation and modeling stuff? Because I'm not aware of, or I'm not sure of any undergrad OSU courses that really get
Mhm.
you thinking a lot about simulation, unless I think you take one of those elective 5,000 level courses. So I'm
Correct.
wondering if that's something uh, that's the process you went through.
Yeah, that plus some undergrad studies, basically. When I was doing
Okay.
undergrad research, that involved some exposure to simulation, and I found that that avenue has a lot of potential and room to grow, basically.
Hmm. Interesting.
Uh,
And so that's what got you into grad school research. The other thing that I think I'm thinking about, since you are one of the few guests who has done bachelor's and masters from here,
mm,
and done it in that one go in the combined program. I'm wondering if there was there's anything that we hadn't covered with our previous guests, which is probably also a little bit of, finding an advisor and finding the right research area. Because when you're an undergrad, maybe you might not have. And I remember, so Mega just did this undergrad outreach event a few months back, where we are trying to target juniors and seniors, hopefully, who were considering grad school or thinking about grad school. And I guess this is a question that we have been discussing within Mega as well. So for any undergrad who is at that stage, and you were at a few years back, what kind of, or how did you go about finding your advisor and finding a research topic that kind of fit well, because you might not get a lot of uh, undergrad coursework experience that directly ties into some of the very niche things that grad
Right.
school entails, right? So
Right.
did you like just go around talking to some of the faculty in our department? Like, how did you land
Mm,
uh, the advisor and that research topic specifically, even within simulation and modeling?
mm. Yeah, I think for people who are already undergrads in the same university, it might be a little bit easier for them versus someone who's coming from outside because you are already exposed to the faculty,
Right,
uh, and kind of know what they do. Sometimes the faculty themselves, they advertise during classrooms. Uh, so it's a little bit easier if you're already in the university. Um,
right.
uh, when it comes to like how to choose, I guess there's uh, if you kind of know what you want, there's not a lot of options. There's usually like one or two faculties that are specialized, or they have something within that domain. So it's usually pretty easy. It's kind of, uh, I feel like thinking back how I chose, I think it was mostly influenced by what courses I
Mm,
enjoyed during classrooms. So, for example, if I enjoyed structural courses, machine design, I'm like more drawn towards computational mechanics or like.
right,
But if I like controls more, then maybe robotics.
right,
If you like fluids, maybe you're drawn into biomed research, those kind
right,
of things.
right.
I think that's usually how it works.
Got it. Got it. And since you're talking about coursework and undergrad coursework, I'm also curious that when you came to the grad studies part of your program, was there again some coursework that also made you decide uh, what you wanted to do here research wise, and maybe expand your uh, research interests per se based on like the grad coursework that's available, and
Mm,
if in any way that also changed your mind for what could be interesting later on that you had maybe not thought about as much as an undergrad, similar to maybe not thinking too much about noise vibration before, but then as you get
mm.
into it, you kind of learn a lot of the nuances in the field.
Yeah. I mean, courses during grad, they were similar in format to the undergrad courses. So it wasn't too much different. But in my case, because I did the thesis-based master's,
Oh, okay.
uh, so half of my masters were just like doing the theses and actual research,
Right,
which is the thing I enjoyed. I like more freestyle investigation, freestyle
right,
research
right,
versus just taking a lot of courses and waiting for that grade and then
right.
graduating. Yeah.
Got it. Got it. Any particular course that you would want to highlight for people who are doing simulation and modeling, and also structures kind of work that you want to highlight to as something that a current grad student that shouldn't miss that course that you found extremely beneficial, if you want to give a shout out to any course.
Hmm. Well, for simulation, I think people don't have much choice. There's only two. One is a technical elective, Introduction to Finite Element
Right.
Analysis,
Right.
And then the second one is also a technical elective, one by Dr. Shah, the
Right.
nonlinear FEA.
Right.
I think those would give you like a solid foundation on how FEA works in general,
Got it.
and then you'll be capable to exploring other domains like NVH or fluid or whatever using
Right.
that same knowledge. I mean, you'll have to learn some differences, but you'll be able to learn and implement. But you need to have that foundation.
Got it. Got it. So other than, I think we have covered kind of all the some of the research questions that at least I had in mind. Apart from that, usually I also talk to the guests about what their kind of work-life balance has been after grad school and working in a particular industry or academia or job sector. So if you're doing a research at a company, what kind of work-life balance and usual keeping up with deadlines and research, what does that look like, and how is that different from grad research?
Mm.
Yeah.
Yeah, I think definitely more work-life balance in the industry. You like typically when in grad school, you take courses in the morning, you come back home, you do research at night,
Right.
and it's a double shift type of thing.
Right.
Uh, in the industry, you're expected to work during the day, and then you come home. You're not expected to work at home, basically.
Right.
Now, there are certain seasons, months where uh, you're required to do some overtime to
Mm-hmm.
achieve to meet some deadlines. And
Right.
those are occasional times, but usually 60-70% of the time, it's it's uh, it's more manageable to have a work
Got it. Got it. That's good. That's good to know.
life. Yeah.
And so before I move on to I think those were all the questions that I and topics that I specifically had in my list here. But before I move on to like our usual final wrap up question, I was wondering if there was anything else that we missed out or we did not discuss about, which you were really interested in sharing with current grad students. Anything about research or uh, hobbies, activities, time at OSU, anything that you would like to share?
Mm, not much because my perspective is a little bit different than right now because it was during COVID.
Right, right,
So
right,
much different experience I
right,
had, maybe not as good as right now. People who are doing grad school right now.
right. Yeah, I remember that those few years, like grad school for grad students was very. I mean, it's always kind of a bit isolated. Everyone's working in their own labs, but
Yeah.
during COVID, it was even more so because even the courses were online on Zoom, so uh,
Mm.
even that even that interaction with other grad students was kind of at a minimum at that point. So I can completely understand. Uh,
Yeah.
yeah.
Mm.
So yeah, without wasting a lot more of your time, the final question that I usually ask all our guests is if there is any particular advice that you would want to share with current grad students or maybe even undergrads because you were in that combined program. And for thinking of grad students in particular, I usually kind of segregate it into three categories. So a grad student who's maybe just starting out versus someone who is maybe in the middle. This is probably more applies to a PhD student who has a long
Mm.
period, and somebody who is a grad student who is like right at the end, finish line, ready to graduate. If you had any particular advice for grad students at these three different stages, and if you have
Mm.
anything for undergrads as well, please please go ahead.
Yeah, maybe I'll start with undergrad first.
Yeah.
So for undergrad, I think if you're like on the line, you're not sure if this is for me or not for me to continue to grad school. I think maybe a good opportunity is to do the undergrad research.
Hmm.
Uh, First, it will look good on your resume, and second, it will give you a taste of what is it like in grad school.
Right.
That's for undergrad. For grad students, I think just pick something you like and don't worry too much about being too like this is too specific. This is going to limit my job search as such.
Right.
Um, yeah, just pick something you like and continue with it, and you'll find something relevant to it. Maybe not necessarily what exactly you did, but something relevant to
Got it. Got it. Yeah, I think that that resonates a lot with what a lot of the previous guests have also said, that part of grad school is uh, just learning a lot of the problem solving skills, and a lot of these different skills, like you might not get the whatever you end up doing because it's so specific, it's very hard or very less likely that you will find like an
it.
exact match. But it's more about just learning how to solve problems, tackle problems, and you can find something that aligns reasonably well with your skill set in the job market once you
Yeah.
graduate. So it's always reaffirming to hear that from one more person.
Yeah.
So good to know.
Yeah.
Uh, yeah, that's my usual checkout question. Thank you, Mohammed, for taking out time for this and doing this episode. Uh, is there anything else that we missed out that you would like to share? Can students connect with you on via LinkedIn or something if they're interested in
Yeah, that's fine.
contacting about your job profile, what kind of work you do at Honda, if
Yeah.
they're interested in that kind of a role?
Yeah. Yeah.
All right. So for all the listeners, I'll have Mohammed's LinkedIn profile in our description. So feel free to contact him if you're thinking about a similar job role, or maybe you're interested in applying for Honda R&D. Most likely, you still have to check out their website because it's a pretty big
Mhm.
company, right? Uh,
Mhm.
uh, and yeah, anything else that I'm missing on before we stop?
I think that was pretty comprehensive. Yeah.
All right. Perfect. That's great. Thank you,
Yeah.
Mohammed, once again for taking
Mhm.
out time for this and doing this, especially on a weekend. Uh,
Yeah.
Thanks once again. Yeah.
Yeah. No problem. Have a good one.
Yeah. You too.